Well, good morning, everybody. Thank you for joining today's webinar from Zero to Hero, Tecplot 360 Basics in 30 minutes. We're going to get you started with Tecplot 360. So if you've never heard of Tecplot or you've just picked up Tecplot 360 and want to get started, this is a great webinar for you. My name is Scott Fowler. I'm the Tecplot 360 product manager. I've been here at Tecplot since 1999 and just really love working for this company and love all the interesting engineering problems that I'm exposed to every day. Feel free to reach out to me or our support staff at any time. You can see my email address there. So if you're not familiar with Tecplot, the company, I encourage you to visit our website, www.tecplot.com. You'll find out everything that we do. We're heavily involved in the CFD community and people who are doing experimental analysis and things of that nature. So please visit the website. You'll find all sorts of great tutorials there. So getting started is really easy by visiting the videos section of our website as well. We're going to show you a live demo of how to use 360. Today we're going to use a 3D flow around a cylinder as our example data set. And at the end, we'll take your questions. So the agenda for today is we're going to show you how to load data. I'm going to show you how to explore that data by turning on and off styles like you see here, isosurfaces and slices. We'll show you how to use streamlines. We'll show you how to calculate new quantities using an equation editor as well as some built-in functions that Tecplot 360 offers. We'll show you how to extract data from your plot for dimensionality reduction. Sometimes you don't need the full volume data and you want to reduce the amount of data you have on disk, so we'll show you how to do some extractions. We'll show you how to do line plotting as well. That's one of the real strengths of Tecplot 360. Compared to other post-processing tools is we have a really full feature set of X, Y, 2D, and 3D plotting. So don't think of us as just 3D. 3D is great for pretty pictures, but engineering decisions are often made with simple line plots, and we do a great job with that. And then finally, exporting. You need to communicate your results with colleagues or your professor or your clients, and Tecplot has some great capabilities for exporting both to image formats, PNG, BMP, and vector formats. And those are great for putting into papers. All right, so let's just jump right into the demo and get started. So if you've never seen Tecplot 360 before, I'll give you just a quick tour of the user interface. What we have here is what we call the menu bar, the toolbar. On the left side, we call this the plot sidebar, and these are all configurable. Width, height, you can dock and undock these. On the right side, I've customized mine, so this may look quite a bit different than what you may see, but I have over here the quick macro panel. I have my frames, sidebar, and probe, and we'll explain some of these in a little bit. If ever some of these sidebars are missing, most of them are available in the view menu. So you can see I'm not showing the pages sidebar at the moment or in the scripting menu. That's how this quick macro panel, the one on the lower right, is displayed. Right in the central area, this big gray area, we call this the workspace or work area. Those are two terms that we use for those. And right here in the middle, we have what we call the welcome screen. And this is a great resource for you for new users, especially. We have all of our documentation linked right here, online resources for tutorials and getting started, and recorded webinars like this one. This will be recorded and posted on our website, so you'll be able to access it here. Down at the lower right of this welcome screen, I know it may be a little small, you have your license number and contact for our support staff. We have support staff in the US starting 6:30 a.m. to 5 p.m. Pacific time, and we also have staff in Germany, working normal European hours there. So anytime you want to contact our support, if you have active maintenance with us, you can contact our support staff and give them your license number and they'll be able to help you out. So it's really nice. You just give us a call and you don't have to go through a big phone tree. You can just call us and get an answer. So one of the really nice guides here that I would like all of you to try using is the quick reference guide. This guide is a It has all the keyboard shortcuts that I'm going to be talking about today. It has command line options if you want to do some customization of Tecplot 360. So please take a look at that quick reference guide. All right, so in order to get started with Tecplot, you need to load data. So that can be done in two ways. The load data button right here on the welcome screen, or you can go up to File, Load Data. And here in my directory, I have a bunch of Plot3D files, grid and solution files. You can see I have about 50 time steps of a 3D flow around a cylinder and the grid here. We do have quite a number of file formats that we support directly. If you don't see a file format that you're using here, we do have a C++ API, also a Fortran API for writing your own custom data loaders. Our Python API can be used to push data into Tecplot. So never fear, we can get your data into Tecplot if you want to. So today we're going to be using our Plot3D loader. I could select it directly here, or I can just select all of my files, and Tecplot will recognize the file type automatically based on the extension and load that data straight away. So really easy to load your data, particularly if it's a recognized format. Okay, so this entire data set, it's all volume data. So Tecplot, to try to save time at when loading, we don't actually load the data until you decide to plot it. So this is a way that we can save RAM and we can save time to first image. So what you're seeing here are the bounding boxes of our volume data. So if we want to see the outer boundary, we can simply click on the contour layer, and this will ask us, it says that all of my active zones are volume, and do you want to show the outer boundary? So I'll say yes. And so we're now displaying our data. And let's show you some keyboard controls for navigating your data. So right now I have the pointer tool, or what we call the selector tool. I have other tools to explore my data, the magnifier or zoom in, zoom out tool, translation tool, and I have a number of different rotation modes here. So what we call a spherical rotation, a rollerball rotation, twist, and then you can rotate around specific axes. It does take some time to go always up to these toolbars, so we have some keyboard shortcuts. So let's just talk about those. So Control right click and drag will rotate. Just right click with the mouse will translate, and middle mouse moving it up and down will zoom. And again, all those keyboard shortcuts are right in that quick reference guide. Now, if you do have one of the rotate tools active, you can just press the O key on the keyboard to define the center of rotation. So now I'm rotating around this corner near me. And if I want to rotate around this far area, just press the letter O on the keyboard. And now I'm rotating about that origin. And here, I probably want to be rotating somewhere around the center. So I'll just hit O here, and now I'm rotating around the center of that object. All right, so nice keyboard shortcut there. Let's look at what data we've actually loaded. So one of the important dialogues in Tecplot 360 is the dataset information dialog. So this shows us some information about the data that we've loaded. You can see that I've loaded 714 zones. So a zone is just a region of data that we've loaded, and associated with each zone we have variables. We have our 3 spatial variables and then conservative variables. Again, this simulation was done using the overflow code and is in Plot3D format. All of the zones are structured data. So you can see that we call that ordered for this first zone. You can see the dimensionality of that data, the solution time that it's associated with, and what we call a time strand. So a time strand may be a new term for you. What is a time strand? It's just a way of identifying a like group of data through time. So if I turn on the edge layer here, we can see each block of data. So for instance, this block, I've single clicked on this, and this has been identified in the lower left corner, zone number 14. So I'll click on zone number 14, and you can see that's associated with time strand 14. If I go down and see this other region number 14. This is also time strand 14. So these are going to be this block through time, so that's the strand. On the right-hand side, we have the variables. You can see that for some of these variables that we have not plotted yet, it shows that the variable status is not loaded. So this is an interesting capability in Tecplot 360 called load on demand. Again, we don't load the data until you actually need it. So this helps keep the RAM low and helps reduce the amount of time that we go out to disk and load the data. Your disk being typically the slowest part of your post-processing. So we really try to limit that access to disk. So for instance, row, we are plotting row, but this is for another time step. So you see it says not loaded. If I advance to that time step, now that data has been loaded, and you can see the min and max values. The dataset tab will just give you a nice overview of the entire data set. You can see that we have, for the whole data set, about 70 million elements in this case. And then the auxiliary data tab has some additional information that's been embedded in the data file. So you can see some of the initial conditions that have been defined for this simulation here. This information may not be in all file formats, but it's something that can be embedded in file formats. In this webinar, we're going to basically go down the plot sidebar and show you the various capabilities that are available here. So we've already touched on contour and edge a little bit. So think of these as power switches. So this is going to turn on and off contour for the entire data set, or this entire frame, this bounding area that we call here. For each individual zone or each individual region, we can alter those individually through the zone style dialog. We can launch that here, and it's automatically seeded with whichever zone we had selected out here. So if I want to look at this region here, I can simply double click. You can see that it's highlighted in the zone style dialog. We'll go to contour, and we can change attributes of that. If we wanted this to use just line contours or flood and line, we can change attributes for each individual zone, or we can do a Control A and change attributes of all of the zones simultaneously. To affect any of these controls, I'm actually right-clicking in these columns to post the menus. So keep in mind that you do need to right-click. So for instance, let's change the line color in this flood and line. We can change this to red. So a lot of flexibility in what you can do with the various styles here. So we'll just go back to plain flooding. Same sort of thing for mesh. If I want to turn on the mesh and say I want one of these zones to be a different color, I can simply right-click here, change that to red. We can also change each individual zone simply by right-clicking directly on it and posting a nice menu here. So here I can toggle on or off mesh. I can change the various colors. We'll change that to blue. Say I don't want mesh, I can turn it back off there. Okay, so again, these act like power switches. So you've seen mesh and contour. Shade is shade. Think of that as solid coloring. So if I just want a region to be a solid color, I can use the shade layer to affect that. All right. Vectors. If I want to show vectors on the outer surface of my data here, I've turned on the vector layer. Tecplot asks us to confirm the vector variables. Sometimes we guess right, sometimes we guess wrong, and we want to make sure that we've guessed right before we go out to disk and load these data. So you can see I have vectors on the surface here, and the vector layer is going to be affected by the variables can be reset here in the plot vector menu, and in vector details we can change the magnitude here if we wanted to. So let's reduce the magnitude a bit. So we have a number of different attributes that you can change for the vector layer there. Let's turn contour back on. The edge layer, again, this is pretty simple. It just shows the edges of my data, and the scatter layer, not really important for this data set, but if you have, say, particles in your data, so you've done, say, a fluidized bed reaction with a code like Barracuda from CPFD, or if you've done a internal combustion simulation from a code like Converge from Convergent Science, the scatter layer is going to be quite important. You can change on the scatter tab the symbol shape. So we have a whole host of symbol shapes, including some 3D shapes such as sphere and octahedron. Spheres can be quite expensive to render, so if you have a lot of scatters, the point, which is just a single pixel, may be a good choice there. All right, now in this case, I really don't want to see the outer boundary. I just want to see the cylinder around which I've done my simulation. And so let's look at how to look at just a single layer here. So this is a structured data set, and I happen to know that the surface of this cylinder is the j=1 plane of these inner zones, but somebody just picking up this data set may not know that. So let's show how we can use the zone style dialog and probing to figure this out. So let's first, we're going to first hide these outer zones. So let's just double click and zone style. So let's go to the surfaces tab. This is one of a little bit more of a hidden feature in Tecplot, but is important to know about this surfaces to plot. So for volume data, I don't want to see any surfaces for these outer zones. So let's just let's close this again, and I will just do shift click to select all these boundaries out here. So now I've selected all these, and I'll hit zone style, and then I can say surfaces to plot none. And then for these that are left over, I happen to know that these are the j=1 plane. Well, how would you know that that's a j=1? I can use the probe tool. I'll come in here and zoom. Again, I'm doing a middle mouse click and click and drag, and I'll hit probe. That brings up the probe sidebar here, and I'm going to look at zone cell info, and you can see down here it says that I've clicked on the j=1 face plane. So as I continue to click around here, you can see that I'm hitting that j=1 plane. So that gives me a pretty good hint that I should just go j planes, and the default is 1. And we'll turn off the edge layer and Control F. This does a view fit, and now I can see just that cylinder. Again, I'm rotating around this upper area. I want to rotate right around the middle, so I'll select my rotate tool and hit O. And you see that my bounding boxes came back. I want to turn those orange bounding boxes off. So I'll go to Options, turn off the bounding boxes. All right, so we've hit zone layers and zone style a bit. Let's move down to derived objects. So we have what we call a derived object. So this is an object that Tecplot produces from the data that you've loaded in. So this is not something that came out of the data file. So let's start with slices. So the slice placement tool is this button here. It's also up on the toolbar. I'll just grab that and click on the cylinder, and I have a constant X plane. If I want to change the orientation of that, I can do that with the keyboard just by hitting Y for a constant Y, Z for constant Z, or A for arbitrary. When you have the arbitrary tool selected, you can go to the tip of this tool to change the normal direction. You can grab the length of this to change the position, and you can grab the ball here in the center to change the center of rotation for that slice. Now again, if I double click, it will bring up the dialog associated with the object that I've double clicked on, or I can right click and get some of the same capabilities that I saw with zones. So say turn on or off the mesh, turn on or off the contour, have to turn on the shade there, etc. Translucency, I can affect the translucency by using this tool as well. So the right click is a really nice, easy way to control the look and feel of the objects. So for the arbitrary slice, I can probe 3 points to define the orientation. I can enter 3 points. I can rotate directly around an axis. So some nice capabilities there. Let's go back to a Z-plane, however. We can show we have what we call a primary slice. So that's this one slice that you see. We can also do start and end slices. So now I have 3 total slices in the view. If I turn on intermediate, we can say put a few intermediate slices in here as well. So you can get a good idea for about what's going on through your flow by looking at a number of slices. So very easy to adjust the slice orientation and the number of slices available. Here we're slicing through the volume zones. If I did want to know what's happening right at the surface, and if I had surface data, which I don't in this case, I could say surface zones. This here is a surface of a volume zone, so I would want to select that, and then you can see that I'm going through all of my volume zones there. Okay, let's go back to volume zones. And just like the zone style dialog, we have all sorts of attributes that you can change about the contouring, vectors, mesh, shade, edge here as well. With slicing, you can also animate through the domain. Let's go back here. The start and end slices were obscuring that. There we go. So you can animate through the domain quite easily using the animate, and that can animate to movie files, which we'll touch on later. You can have up to 8 different slice groups. So if I wanted to show X slices, Y slices, and Z slices all simultaneously, I could do that as well by using multiple slice groups. And a slice extraction. So we did talk briefly about dimensionality reduction. If I don't want to keep the entire volume data set, I could extract this slice to a zone, and then I can write that zone data out to disk to reduce the amount of data that I'm maintaining. That's a nice capability. Okay, slices are a great tool for not just visualizing your flow and what's going on in your domain, but it's also a useful tool for figuring out where to put an isosurface or seeding stream traces. So let's move on to isosurfaces now. So isosurfaces, we can, here I want to define an isosurface using the row variable, and I want to show that isosurface at a specific value. Now, I don't know if this is necessarily a good value, so let's again use the probe tool, and we'll probe on an area of interest here. So as we zoom in, I can see that I have a nice demarcation between contour levels. Let's click right here and go to variable values, and we've got 0.0833. I'll just copy this and paste it into here and turn on the isosurfaces. So again, this toggle over here, these are like power switches. So if I had multiple isosurface groups or multiple slice groups displayed, I would turn on and off all of my slices and isosurfaces by toggling these, or I can toggle on and off an individual group here. So now I have an isosurface going through my domain at a nice location. Let's make that slice translucent so we can see through it a bit. And we'll hit play and animate through time. So again, as we're animating through time, I'll touch back on Tecplot's load on demand capability. So we haven't loaded any of these time steps that are in the future, and as we're animating through time, Tecplot is loading that data real time and rendering it. And we hold on to that data in RAM. So some people say, gosh, Tecplot looks like it's using a lot of memory, and that's true. We hold on to as much data in RAM as we can, but then we will start dropping data from RAM as we reach the RAM limit on your machine. And you can affect that by options, performance, miscellaneous, and you can adjust what we call the load on demand memory threshold. So if you don't like how much RAM Tecplot is using, you can drop this down to a lower value and we'll start unloading data earlier, but that just means that when you go back to an earlier time step, that data may just be resident on disk instead of in memory, and it'll take a little bit longer to load that off disk. So nice capability there. All right, again, isosurfaces, just like slices, they have the ability to be right-clicked on to show the various layers, mesh, vector, shade, translucency, and all of the similar attributes for adjusting those are available in the isosurface details dialog. Again, you can double-click on the item to bring up the dialog associated with it. You can right-click and bring up the dialog there as well. And again, isosurfaces can be extracted through the Tecplot 360 user interface as well. Okay, let's move on to stream traces. I'll turn off the isosurface to make this a bit more understandable as we add stream traces. Stream traces can be added very easily just by click and drag. So by default, we add 10 stream traces in what we call a rake. You can also single click to add these. This is a volume line stream trace. So you can see as I go to the side here, you can see these stream traces go up and down. So these are not surface restricted at this point. If I bring up the stream trace details dialog, you can see that we have a few different types of stream traces that you can add. Volume line, volume ribbon, volume rod. Those are going to go through volume data. The surface line stream trace, this is going to be a surface restricted stream trace, and that does have to be added to a zone. This being a slice, we can't do surface restricted stream traces on a slice, so that would be an opportunity. If you do want it restricted to a surface at this location, you could extract that slice to a zone and then add the stream trace there. And so let's delete all of these stream traces and I'll demonstrate each one of these stream trace types. So volume line, and I'll grab my placement tool. We'll just do single click to add the volume line, the volume ribbon, and the volume rod. We'll zoom out here and come to the front. Again, I'm doing control right click to rotate, middle mouse to zoom, and we can see each one of these objects. So you can see a line is simply a line, and we do render arrowheads on here. You can see some of those arrowheads kind of dip and dive and are obscured by that slice. The volume ribbon, just a flat object, and the volume rod, we default it to 3 points. If I go to the rod ribbon tab, I can adjust the number of points. So if I want this to look nice and round, I can do that. 3 points is actually kind of nice because you can see twist in your flow using the rod, and it's a bit more of a three-dimensional object here. You can also adjust the width. So let's make each one of these a little bit wider, so that affects both rods and ribbons. We can also adjust the coloring of these. So now these are colored by row. And if we turn off the slice, you can now see those ribbons. We can animate these. So these are animated. This is at this particular time step, instantaneous velocity. And you can see how those animate. When you're done animating, we leave it in a mode that shows what we call timing markers and dashes. So if you go to the timing page, you can see the markers can be turned on and off for the volume lines. Dashes affect all three of these types. Now, occasionally you may have flow that is very, very slow in a region, and your stream trace may stop prematurely. Here you may want to, and this is a pretty rare case, but the integration tab is pretty important here. You can adjust the minimum step size or increase the number of steps that a stream trace takes across a cell to get a stream trace to propagate through a very slow flow. All right, so that's streamlines. You noticed when I right-clicked on the slice to hide it, it did not turn off the power switch, but it turned off show group. So we'll bring that slice back. All right, let's talk about calculating variables next. So we've kind of touched through most of the sidebar. Actually, before I go on to calculating variables, let's just talk about the lighting effect really quickly. So lighting, you can change the light source position through the use of this tool. So you can get some pretty striking looking plots using by adjusting the lighting position. And translucency, again, this is like a power switch for the zones. So if I turn off translucency, you'll see it affects zones, but not the slice. So again, these affect zones primarily. All right, so calculating new quantities. If I want to calculate a new value, I can do that in two ways. Data, alter, specify equations. So I can type in a custom equation here. So if I wanted to calculate a radius variable and say I want to do an isosurface at a constant radius, I could calculate a radius variable here. I can affect what data type it is. So if I know that I want to save some space when I write out a file, I can use single precision instead of double precision, or if I want that value to show up at the node locations or at cell centers, I can affect that as well. So this is a very nice dialog. But we have some built-in equations as well. So that would be under the Analyze menu, Calculate Variables. So in this case, I'm going to compute velocity magnitude. Hit OK, and hit Calculate. And this is, again, like Load on Demand, we have what we call Calculate on Demand. So we haven't actually calculated velocity magnitude yet. We've just set up the equation, and we're not going to calculate until we need it. So let's change the contouring to use that new variable. So we can do that through the Contour Details dialog, or a shortcut that I like is just double-clicking on the legend, and that will bring me right to the Contour Details dialog, and then I'll just select Velocity Magnitude. And this has now changed the contour coloring for every object that referenced what we call Contour Group 1. Okay, so now I have velocity magnitude plotted, and so we've actually calculated that real time, and then as I advance through time, we're doing that calculation as we advance through time. Okay, and we can hit pause here. Now we're going to move on to some data extraction. We've already touched on it a little bit through the slice dialog with the extract toggle and isosurface. You can extract. Other extract options are here in the extract menu. So you can extract, again, isosurfaces, slices, streamlines, and you can extract these objects over time. You don't see slice over time. That's because we've moved the overtime capability right into the extract slice dialog here. The extract that I'm going to do today is I'm going to extract a single point through time using the probe to create time series plot. So I'll just select this option, and you see I have this set of crosshairs. Click right there. And I have my velocity magnitude through time very quickly, and these are linked together. Okay, this also highlights Tecplot's multi-frame capability. So we have 2 frames showing 2 different data sets, and these are linked in time. And let's move on to getting this ready for final plot. So we'll talk about exporting and some of the capabilities in line plots. Looks like I'm getting a little short on time. This is supposed to be a 30-minute webinar. It looks like I'm 5 minutes over. I'm close to done here. So thanks for your patience and attention. Okay, so I've moved my frame up here. I want to get this ready for final production. So I will go to Frame, Edit Active Frame, and let's say I want to turn off the background, turn off the border, and let's show some nice grid lines on this plot. All right, so now I have a nice looking plot that's ready for production, and I can animate this to a movie. I'll pick MPEG-4. We could go to a sequence of images, which is really nice as well. And the region, I want to export all frames to this movie file, and we'll just hit OK and save it to an MP4 file, and that's rendering. And if again, if you have any questions, please type them into the question pane, and we'll get to those right here at the end of the webinar, so we can be all prepared for that. Looks like this is awfully close to done rendering here. It's going through the time steps. And I'll just get this file ready to come up and show you this. Looks like we're about halfway through. So again, as we're animating, we're loading that data, we're calculating that velocity magnitude, we're rendering the image to a temporary image file, and then we're going to compile all those images to a movie. And as that's animating, I'll point out that we do have, again, export to raster formats such as PNG, BMP, and vector formats, PostScript, EPS, for example. The PostScript files are great for line plots. Those vector formats are great for line plots. The raster formats are great for the 3D plots. Okay, so it looks like this is almost done. There we are. And let's just bring up this this movie file, and you can see what that looks like. All right, and that's just going to loop. Okay, so a couple of questions have come in. How do you save all the steps to a macro? That's a really good question. So Tecplot does have two different scripting languages. On the scripting menu, all of the steps that I've taken today, you can record those to a macro file. This is what we would call our legacy scripting language. It's also the language which many of our file formats are based on. So we have ways to customize the Tecplot 360 user interface using the quick macro panel. You can customize defaults using what we call a configuration file, and if you save say a layout, so we can save the work that we've done here. I'll just save that. It's asking me to save the file that I created, or the data that I created here. So I'll just save that to line data. So this this layout file that I've saved is in this macro language. So you can record all those steps to a macro file. You can also record to PyTecplot. Why is the cylinder surface not showing velocity magnitude? Well, this is a no slip wall here. So being my boundary condition, I have no velocities on the wall. If I want to see the velocities near the wall, I could change J-planes to say the J equals 2, and that looks like velocities are still very, very low at this location. Let's probe and see what we see. So rho UVW, they're very small, so we may not be seeing velocities there. Okay, can we plot stagnation energy? Well, let's see. We may have. I know that we have stagnation. Yeah, stagnation energy. So that's a value that could be computed. Okay, how do I export a figure without a border line? So that can be done by editing the active frame, and you can just turn off show border, and then the border won't show up on the output. There is a some graphics cards will have a little drop shadow on the right and bottom of the plots. It's graphics card dependent. We do have a knowledge base article on that. So if for some reason when you're exporting a plot and you do see kind of a little drop shadow on the right and bottom, just search our knowledge base for frame border, and I think that'll come up. Okay, so when I save a layout and move the layout to another folder, it's not loading. Yeah, that's a good question. So when you say save layout as, there's a toggle down here that says use relative paths. So the data that the layout file is referencing is going to be saved as a relative path by default. You can uncheck that to save as an absolute path, and then your layout should load just fine. You can also edit the layout because they are human readable. So let me just bring that up really quickly, and you can see what our macro language looks like. So here I've the layout that I saved earlier. You can see that I have a command here to point to line data.plt. So if I did move, if I wanted this to be a absolute path, I could change that right there. The nice thing about using relative paths is we have people who are doing optimization studies, and they have a whole folder hierarchy that has data in it. And by having a relative path, if I had say a mock alpha sweep and data within each subfolder, I could just copy a single layout into each one of those subfolders, and it will load that data by relative path. Okay, can you repeat extracting the line plot? Sure. So what I did to do that is I used tools, probe to create time series plot, and I do a single click on the plot, and I'm and that will update my time series plot. So you can see as I click, that updates that through time. Is it possible to export a cropped image? I don't need the whole working area in the figure. No, not really. Tecplot will export, well, actually, yes. Let's take a look at the options here. So we have the region, all frames, current frame, and work area. So work area is going to export this entire gray region. So I guess if I wanted to crop, I could do what we call a paper zoom. So I'm holding down the shift key and I'm zooming in, and so I'm kind of bringing everything closer. And so a work area export is going to crop or export everything in this work area region. I don't know if that exactly gets you what you want, but that's an option that you could use. Can we animate the time series plot through a line? So I'm not exactly sure what you mean there. Why don't you contact our tech support group and give us some example data, and we can work with you to get exactly what you want. We have a lot of capabilities that we haven't gone through today, and we can work some magic for you. Okay, how can I get two plots in the same frame? Well, in my line plot here, I can go into the mapping style dialog, and you see that we have multiple y-axes. So let's say I want row and velocity magnitude to show up. If I do a Control F, that's a view fit. These have two very different scales. So I could say y equals 2, and now row is on that axis. Let me turn the frame borders back on. We'll make this a bit bigger. Let me turn on the background as well so we can see this plot a little bit better. If I go to the lines page, I'll, for both of these, change the line thickness to be a little bit larger. So you can see that I now have two plots in the same frame. Use the adjuster tool to move this label. Okay, can I add LaTeX symbols to the legend? To the legend, no, but you can add LaTeX to as just a simple annotation. So that's through the text details dialog. You click where you want it, and you can press the LaTeX button. And I confess I'm not a LaTeX expert, so let's see if I get this right. Yeah, there we go. And let's adjust the size of this. So in the contour legend here, you could say show header no and move that guy down there. Let's turn off the legend box. So that kind of mimics it, but you can't adjust the header directly through the dialog. So. Okay, so another question about two frames in the same graph. I'm not sure I understand your question. Let's take that offline. Please, I would ask that you contact our support so we can dig further in. I've got to the definitely way past the end of the webinar. So any additional questions that you have, please contact our support staff, and we'll try to answer those offline, and we'll document all the answers to your questions when we publish the webinar. So I appreciate your time today. Thank you very much. Let's do just one more slide here. I do want to close by saying that yes, we will publish this webinar, and we're going to send you a survey. So this will help us improve our webinars in the future. And we've got to your questions. And then if you do want more training, you can go to our webpage at the Getting Started link here, or look at our videos. And we also have a training certification that you can click on as well. So again, thank you for your time. Thank you for your attention and all the really good questions that you've asked.